Hello, welcome back. We are now, sorry about that. We're now on page 55, level 2 of Unit 8 here for this first skill. And now we're going to talk about radicals that don't fit this category, right? So when we had a square root of like 9, we knew that was 3. If we have the square root of 25, we knew that was 5. Well, now we're going to talk about numbers that are in between. So for example, like the square root of 20, right? The square root of 20 has to be some number between 4 and 5. So, I mean, you can get a decimal approximation for it. But we're also going to talk about how to reduce the radicals. So instead of square root of 20, we can rewrite it so that the number inside, the radicand, is as small as possible. And that'll be very helpful in other applications like in geometry and moving forward. And so it is a good skill. Plus, you know, on the SAT and ACT, everything's always reduced with the radical. So you'll never see the square root of 8. Even if that's the answer, you won't see it written that way. You'll see it written somewhere, a different way. And now here's how we can reduce or simplify these radicals. Okay, so there's really two options. I'll show you both. And it kind of depends on, you know, where you are with the mental math and if you're pretty quick with multiplying and dividing. First option, so let me do number 8. So first option is you find largest square number that goes into the radicand. So you find the largest square number that goes into radicand and rewrite it using that number times whatever is left. And so here's what I mean by that. Let's do number 3. Okay, so, and this is with option 1. If I'm trying to find the largest square number that goes into 60, I'm looking at this list right here. So I know 1 goes into 60. I know 4 goes into 60. And 9 does not. 16 does not. 25 does not. 36 doesn't. And once we've gotten about halfway there, you don't really have to check the other ones, okay? I mean, you could, but it's not going to work. Okay, so 60 is over here, and the largest number in this list that goes into 60 is 4. So what you would do is you rewrite it as the 4 times, and then you have to actually figure out, okay, well, 60 divided by 4 is 15. Okay, so that's one option. And then, now what you can do is actually split up. Since we're multiplying, you can split up the radical and square root each number individually. And what that does for you, since the square root of 4 is a perfect square, you can reduce that to just 2. And then the square root of 15 is what remains. And so now we've reduced the radical from the radicand from 60 to 15. And in the process of doing that, we essentially pulled out a 2. Okay, so that's how you can do it with the first option. The second option looks something like this. Okay, so let me use purple actually. So the second option looks something like this. You basically just you do a factor tree for the number in the inside, so the radicand, and look for pairs. For every pair, you take 1 out. Okay? And so that seems kind of confusing when you write it out, but essentially here's what it looks like. So here's option 2. So I have the square root of 60. And we're going to break down 60 into a factor tree. And to do this, it doesn't matter how you do it. You can start with 10 times 6, or 3 times 20, or 4 times 50. It doesn't matter. You're always going to end up in the same spot. So for example, let's say I'm doing, okay, what multiplies to 60? Well, I know 6 and 10 does. Okay, so far I got 6 and 10. But we want to break down every number as much as possible. So for example, I know 6 is 2 times 3, and I know that 10 is 2 times 5. Okay, now 2 doesn't go any further because the only things that multiply to 2 are 1 and itself. Same with 3. 3 can only be rewritten as 1 times 3. Same with the 5 over here. So once you get it down to this level where there's no more reducing that you can do, so I kind of circle all my factors. So I have a 2, a 3, a 2, and a 5. Okay, and so now I look for a pair of numbers. Well, right now I see a pair of 2's right here. And so here's one pair of 2's, so that means 1, 2 comes out. And I don't see any other pairs inside here. So then whatever's left, mainly this 3 and this 5, you re-multiply that out. So 3 times 5, that's going to be 15. And we're done. Okay, so every pair, you pull out one of them. If we had multiple pairs, like let's say I had a 3, and then a 2 and a 2, you would take out a 3, you take out a 2, and then you would multiply everything out here, and then multiply everything on the inside to get your final answer. Okay, but you can see either way, you get the exact same thing. Okay, so I will do one more problem with both scenarios. Let me do this one. I'll do number 9. Okay. So again, I'm going to go option 1 first, just so we can compare. The negative 10, I'm just going to leave. Okay. But the 72, I'm going to split up. And again, if I'm doing option 1, I'm trying to find the largest square that goes into there. And if I'm looking at this list, I know that 9 goes into 72, and 36 goes into 72, and that's it. So 36 is the largest that goes into there. And so what you would do is you would rewrite the 72 becomes 36 times 2. And I always recommend writing the square, write the square number first. Okay? So then now what's going to happen is you have the negative 10, and just like in the previous example, you can split this up and do square root of 36 times the square root of 2. And now you simplify. The square root of 36 is 6. So we have negative 10 times 6 times the square root of 2. Negative 10 times 6 is negative 60. And so this would be negative 60 root 2. Okay? And so that's with the first method. Now using the second method, okay, again it's similar. So I'll start with the 72. And we're just going to break it down until we can't any further. So let's see, 72, I know that that's 8 times 9. And again, you could have started maybe 6 and 12. It doesn't matter how you start, you're always going to get the same answer in the end. Anyway, so you have 8 and 9. I know 8 is 4 times 2. I know 4 is 2 times 2. So 2 is good, 2 is good, 2 is good. 9 I know is 3 times 3. And so here's my final product, right? 2 times 2 times 2 times 3 times 3. Remember, for every pair, we take one out. So here's a pair of 2's. So a 2 comes out. Here's a pair of 3's. So a 3 comes out. And now what's left? What's left is just this single 2, and that's going to go on the inside. And now you multiply these numbers in front, so you get 2 times 3, which is 6 root 2. Okay? And so now going back to this, remember we still had the negative 10 in front, and so that negative 10 is going to get multiplied with the 6 square root of 2. And obviously, negative 10 times 6 is negative 60. And so both ways, you get the exact same answer. Okay, so it's really just a matter of preference. Okay, if some people are really good with the squares in their heads and they can see it, like for example, I'm looking at 50 right now and I see 25, and that's going to make things easy for me. But you may not see that as fast. So if that's your situation, I would recommend using the tree method, the factored tree method. But either way, this isn't too bad. You just got to practice to get better. All right, so thanks for tuning in, and see you next time.